What is a radioactive isotope? Vikram, I see that hand. What is a radioactive isotope, Vikram? Put your gum away and don't give any to anybody. Nope. You weren't paying attention. You can have gum later. What is a radioactive isotope? Let's start with what's an isotope. What is an isotope? An atom? A kind of atom? What is different about that kind of atom versus other kinds of atoms? Can you explain what you meant, Angel, by okay. What's an isotope? It is a different kind of atom. That is correct. What is different about this kind of atom? Isotopes have something special, something extra.
Oh, they have more mass.
They have more mass.
Yes.
What gives them more mass?
It's like more neutrons.
More neutrons, very good. So that is an isotope. When you have certain isotopes are radioactive, what does it mean for these isotopes to be radioactive? The extra mass needs to make something about the isotope true. Elijah. Makes them unstable, very good. So a radioactive isotope has been made unstable by its extra mass. And Angel, what does the unstable extra massive isotope do to make itself stabilize? Yes, doing by what processes? You went choo, 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 choo. That is correct. I just need the names for choo choo and chew. What are the names in Paris for choo choo and chew? Alpha decay, gamma decay, and beta decay. That is the answer to all of question 1. Yes. Am I throwing it, or are you coming to get it? It's probably going to break, and it's nicely sharpened. I also don't want to stab Kiwana in the head. I don't want to stab Numrit in the eye. So I'm going to suggest that you come over here and get it. Thank you. Okay, so question number 2. Question number 2 said, how are nuclear fission and fusion similar? How are nuclear fission and fusion different? Okay, what can you tell me about nuclear fission and nuclear fusion? How are they similar or different, Memphis? Yes, fusion is combining small things to make something bigger. And fission, taking something really big and having it split up into smaller bits. Yes. That is one difference between fission and fusion. What is another difference between fission and fusion, Malik or Numrit? Do either of you know fission fusion differences? Okay, then stop talking to each other and pay attention. Put your phone away, Malik. Vikram. Actually, no. Well, kind of. Sort of. Depends on why. Why? It's not entirely true. It's sort of true, but not entirely true. More energy per what? I know. I said, but I qualified it. I said more energy is available from fusion for a specific reason. Because fission actually releases more energy. It's because they're smaller. Fusion releases more energy because there's more packed into that small space. So fusion releases more energy than fission. What is another difference between fusion and fission? There's a big one that I'm looking for. A very significant difference between fusion and fission. Nope. I mean, that's true. Fusion is uncontrollable, fission is controllable. That's not the difference I'm looking for. There is a substantial difference between fission and fusion. Elijah, you had your hand up a second ago? No. Dennis, do you know? Cool, let's stop talking to Liam. Lamise, I saw that hand up. Did you have the answer? But you put your hand up. Oh, so, okay. Okay. Michael. Yeah, it is. What's the difference with radiation? Nuclear fusion is not radioactive. Good. Fission produces a whole bunch of radioactive junk. Fantastic. That basically covers the difference. Everything you guys have said covers the differences between fission and fusion. How are they similar? The similarities are really low level. Why would anyone want to do either fission or fusion? They are phenomenal energy sources. That's answer to question B and A. All of question 2, there it is. Both release lots of energy. How are they different? Fission splits smaller, produces radioactive products. Fusion combines to get bigger, not radioactive. Very good. And the last question, can we produce energy using nuclear fusion? The answer is no. I told you yesterday that it was like 14 seconds was the record. I was very wrong. As of February this year, the current record is 22 minutes for fusion, sustained fusion. The record is a lot bigger than the last time I looked at that number. Back in February 2025, so the February of this year, a French fusion reactor managed to sustain fusion plasma for 22 minutes, which is pretty good, pretty big deal. Okay, so a unit on energy would not be complete unless we talked about how all of these energy transformations impact our planet. And so there are certain topics that just get beat to death over the course of your academic careers. I'm willing to bet that there's things that you hear about year after year after year, and one of them is what we're going to talk about today. When you think about energy transformations and our planet, what big deal do you think is going to come up here?
I have a question.
Yes.
It's like radiation before the environment, or
No, generally no. Vikram. Yes, but the sun is only a part of this big topic. No, we are going to talk about that though. Yeah, climate change. Climate change, climate change, climate change. It's one of those things that comes up every year. And the danger when it comes up every year is that it loses its impact. Oh, we're just going to talk about global warming now. Heard about global warming last year. Yeah, we're talking about it again, so here we go. Do what you can to see this through a new lens. I'm going to try and show it to you through a new lens to minimize the eye rolling and the, oh, here we go, we're going to talk about this again, business of climate change. If you still don't believe that climate change is happening, I'm not sure I can convince you. If you think it's not happening, you're wrong. I'm just going to go out there and say that. And if you would like to remain wrong, you are welcome to remain wrong. But here we go. Yes, Vikram. The global average is still going up. No, it has not. It has not gone down. It went down. We know. Well, we'll talk about different things in a sec. Okay, so here we go. So this lesson, Luca, is all about energy transformations and global systems, Dennis. Here we go. Earth is a system in which energy is transformed. That is not an earth-shattering truth. You should all be familiar with the fact that even if you're limited in your understanding of the natural environment, Malik, if it's your phone again, I'm going to take it from you. That Earth is one big energy transformation system. The wind, weather, ocean tides, currents, Volcanic activity, mountain formation, all of it on Earth, all due to energy transformations, different kinds. What makes wind? Why is wind a thing, Himparis? That has something to do with the direction of prevailing winds, but where does the winds come from? That is part of it. That is ocean tides. Ocean tides are the moon's gravitational pull. The moon's gravitational pull does not affect the wind directly. What makes wind wind? Sorry? Air moving. Okay, cool. Why does air have to move? Air only moves if other air gets out of the way. So what kind of air has to move first? Does anybody know what air does the moving first? No, helium's not air. Lamise, I saw that. No, it's not a hand. Dang it. Air. Air's moving. What air moves? No. 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 Not what part of the air. What air? There it is. Hot air. Hot air goes which way? Up. Cool. So when you get hot air rises. It is less dense. It goes up. It floats to the top of the atmosphere. If it only goes up when it gets hot and nothing comes to fill that space, you have nothing to breathe and now you die. So as the hot air rises, cold air rushes in and takes its place. It gets warm, it rises. Up top, it's cold. So then the hot air that was hot, that rose, becomes cold, slides back down and around. And it's this looping that makes wind. That heat has to come from somewhere. Generally, that heat comes from the sun. This impacts weather. Ocean tides are caused by the moon's gravitational pull. Very good. So that's gravitational potential energy. Currents caused by tidal shift and the spinning of our Earth. Volcanic activity. What causes volcanic activity? Tectonic plates. Why are tectonic plates a thing? Because the continents are floating up top, colliding. Cool. Why are the continents floating? Because it's too hot down there. Why is it hot down there? There's a couple reasons. Sorry? What makes the Earth's core hot? Two things. Pressure caused by gravity, and another source of heat down inside the Earth is... Nope. No. Lava is because it's hot. Lava does not cause the hot. I said lava is caused by the hot. It does not cause the hot. He already said that. Pay attention. Why is the Earth hot on the inside? Gravity is one reason. That pressure keeps things hot. There is another reason. There are little things down there generating immense amounts of heat. What are they? No. Not fission. Yes, fission. Yes. No, sort of. Decay. Nuclear decay. There's a whole ton of radioactive material down in the Earth. Volcanic activity and mountain formation are due in part to large amounts of radioactive material inside the Earth. So, all of these things are due to energy transformations. Solar energy, wind and weather, gravitational potential energy, and nuclear energy. All play important roles in Earth's system. All stuff that we've talked about. The only thing that we've talked about this semester that doesn't have anything to do with the Earth is springs. But springs are fun. It'd be cool if the Earth was full of giant springs. If you discovered that the Earth was full of giant springs, that's a Nobel Prize waiting to happen. But, springs. We did talk about springs. Nothing to do with the Earth. Okay, so solar energy, let's talk about it. Solar energy has the single greatest impact on the Earth. Because if the sun weren't there, we'd all die. Two ways. What are the two ways that we would die if the sun disappeared? Freezing to death is one. What is the other way we would die if we were somehow able to bundle up? What is the other way that we would die? Sorry? before then. Before we starve, no, it would not be vitamins. Lack of? No. Vitamin D doesn't kill, never killed nobody. Why is that a problem? No, that's not what's going to kill you. We got flashlights. No plants means no photosynthesis. If there's no photosynthesis, there's no. What is the product of photosynthesis we need? Oxygen specifically. I don't know, I didn't hear it. So, solar energy cuts off. Photosynthesis is a huge part of the solar energy from the sun. Solar energy comes in. The other thing that solar energy is wildly important for is the water cycle. You've learned about the water cycle before. The water cycle is evaporation, condensation, precipitation. This is the water cycle that you learned about when you were in preschool. Also maybe grade 9. You missed preschool? Some people miss preschool. I didn't go to preschool. Did you go to preschool? Oh, my parents loved me, so they kept me home. But I sent my kids to preschool. I'm kidding. I sent my kids to preschool. So, my mom didn't have a job. That's why I didn't go to preschool. Okay, so the water cycle. The idea that, yes, you may have learned about it in grade 9, but it's the idea that the evaporation, condensation, and precipitation loops water in our atmosphere and on our planet. Why do we in BC care so much about the water cycle?
Because we're powered by hydro or dams.
Why do we want that? Malik, louder. Everyone listen to Malik. Shh, Luca, stop talking. Malik, say it again. Oh, so sad. BC Hydro. BC Hydro is called BC Power, or BC Hydro is called BC Hydro, Vikram, because so much of the power that we get, we benefit from having these big hydroelectric dams. Water flows over, spins the turbine, generates power. You also learned about that in grade 9. If that doesn't happen because we don't have any rain, now all of a sudden BC's got a problem. We become no better than those filthy prairie provinces that have to burn gas and coal to power themselves. Or, I mean, they got solar, they got wind, but they've also got a lot of oil to burn. Okay, flip the page. That's solar energy. Nuclear energy, I already said it once. Let's finish it up. Nuclear energy inside the Earth. It is Earth science-y, yes. Yes, Gemini. Nuclear energy is transformed into thermal energy inside the Earth's crust. This thermal activity drives tectonic plates to move and is the source of not all, but some volcanic activity. Hotspots. Hotspots in the Earth are due to, there's a lot of talking underneath me here. Angel, stop talking. Imparis and Vikram. Vikram, if I have to ask you to stop talking again or messing with Imparis and stuff, I will move you. You will go sit over there by Kanchan, and she will shame you into not talking. Hotspots, radioactive locations inside the Earth. Oh, apparently you're not going next to Kanchan because Lamise just saved you. You're going to go sit next to Ickpreet and Olive, which is arguably worse. They will be meaner to you than Kanchan ever would have been. Right, ladies? Yes? We're going to be mean to Vikram? Good. Hotspots inside the Earth, as these tectonic plates move around, create some cool places. Does anyone know where the coolest volcanic hotspot is? By coolest, I mean most awesome. Hawaii. Hawaii is created by a hotspot under the Pacific Ocean. And as the plate moves over top, new islands get formed. So the plate is actually moving towards Japan. And so you get all these tiny islands. And the hotspot is currently underneath Kona, the big island. It's been there for a long time. That's why Kona is, of the Hawaiian Islands, currently it's the most volcanically active because it's right on top of the hotspot. There's another hotspot actually just southeast of Kona. And what that means is if the plate sits there long enough, we might get a brand new Hawaiian island. And I don't know about you, but I love Hawaii. I've been there once and I want to go back desperately. More Hawaiian islands is never going to be a bad thing. Yep. Malik. Yes, geothermal. It's harnessing the heat to boil water. Spin the turbines with the steam. There is another massive hotspot underneath North America. This one is not awesome. Well, it is sort of awesome. It should be terrifying. It's classified what's called a supervolcano. And it is underneath the great state of Wyoming. What big park is located in Wyoming? It's named after a color. Yellowstone National Park sits on top of a volcanic hotspot. It is what's called a supervolcano, and if Wyoming explodes, which it could, we're in for a world of hurt. So there's hotspots kind of all over our planet contributing to the volcanic nature of our planet. Yes. The nearest volcano to us is probably Baker. It's the White Mountain right there. You go outside, you look at that White Mountain that's like southeast of us is a volcano. Absolutely it could. No, I am totally serious. I have no idea. But I have already scoped out where I'm going to be if that thing goes up. I want to watch. And so I'm not going to tell you where. Oh, absolutely there's a chance. There is a chance that either that Mount Baker absolutely erupts in our lifetime. Totally. Yeah. Probably not. No, we will not. It will almost certainly not kill us. We are far enough away. It's not going to get to us, but you are definitely going to be front row seats. It's like SeaWorld. You're not in the tank with the whales, but you're in the splash zone. Like, we have a front row seat to all the death and destruction that's going to happen in the States. We'll be okay. It's not that close. Like, Mount Baker is still a good 5-6 hour drive away. Even though you can see it right there, it takes a while to get there. So we'll certainly be covered in ash. But that's not going to kill anybody. It's just going to be real dirty. No, there is not a way to make it blow up. Okay, so that's nuclear energy. Here we go, gravitational potential energy. There are a few ways gravitational potential energy is useful to us. One of them powers our province, BC Hydro, and that is, it's just falling water. If you put a big scoop in the way of falling water, the big scoop's going to spin. You hook up the spinning scoop to a turbine, turbine's going to spin. You spin the turbine, put some magnets on that sucker. Now, all of a sudden, you have a source of alternating current. You want to know how that happens? You got to take my Physics 12 course. That's where we talk about how turbines actually go about creating current. What? Yeah? No. I teach physics here. No, here. Here. Right now, I have 2 Physics 11 blocks. Yeah. Not summer school. Right now. So that's part of this. Another way that gravitational potential energy powers our province is through something like this. This is a tidal generator. We don't use this a ton off BC, but we do a little bit. The really big place that this gets used, also in Canada, does anyone know where the world's largest tides are located? Definitely not White Rock. It's in Canada. The world's largest tides are located in Canada. No. Niagara Falls is a waterfall. Don't talk unless you have a serious answer. No, you're close. It is a bay. It is out east. The Bay of Fundy. New Brunswick. It's the east coast of New Brunswick. It's the world's largest tides. And when you have big tides moving, those tides move a ton of water. And if you can harness the flowing in and out of all that water, again, you can use it to spin a turbine, and those spinning turbines can generate alternating current. The moon is responsible for those ocean tides. It's the gravitational potential energy of the moon creates those tides. When you're ready, flip the page. Hey, Avatar's got to be good for some because it wasn't a very good movie. At least I didn't enjoy it. I didn't like Avatar. I am talking about not the Avatar The Last Airbender. I'm talking about the Avatar made by the guy who made Titanic. The blue Avatar. I didn't like it. I didn't like it. It's a remake of a movie that's already existed. Here we go. So, concept number 2. The sun provides solar energy, which is both good and slightly problematic. This solar energy is transformed into thermal energy. This right here, this block of energy, Malik, stop talking, please, is, Luca, the light the sun is providing. This is the sun's light in. Solar energy shows up to us as ultraviolet, visible, and infrared light. Earth spits it back out into space this way. Earth's energy out. And it's this difference in wavelength provides a difference in energy, and it's this lower energy light that gets trapped in our atmosphere. Yes, I can. Like that? Is that enough? That's as far as I can go. Okay, so I'm sliding down here. The sun's solar energy consists of visible light, infrared radiation, and UV radiation. Here's how it works. Sun's light comes in. High energy or higher energy. And Earth is a big reflective surface. That's why you can see it. So it reflects light up. Great, that's so awesome. It bounces the same kind of light that came in, tries to bounce out. Some of it gets trapped here. Some of it never makes it down because it's reflected back out by clouds. And just so we're clear, it's none of this that contributes to global warming. The stuff that bounces up off clouds and the stuff that bounces straight out is great. We like this. It's allowed to leave. It helps us regulate the temperature of the Earth. The problem comes when a whole bunch of it gets absorbed by the surface of the Earth right here and then re-radiated back out as lower energy, and it gets trapped. There, it gets trapped. Here, it gets trapped by bouncing. Yeah, these are the places that are problematic. It gets reabsorbed by the atmosphere and absorbed by clouds on its way back out. Now, we need this to a degree. To a certain degree, we need this. We need Earth to be warm enough to be habitable. But what's happening, the problem with this is more energy. I'll move this over here. More energy is being absorbed than is needed. And as a result, climate change. Yes, Imparis.
Just a random question.
Yeah, I'm all about those random questions.
So, how much time, how much energy would we need to travel at light speed?
Infinite amounts.
Oh,
Actually, and I'm not just making that up. Like, you would need an infinite amount of energy.
so what was 99.99%?
Well, that's different. Lots, but not infinite. Because the problem in Paris that you don't know, because you've never taken a special relativity course, is as you reach the speed of light, and I'm going to flip the page here in a second, so if you haven't written this down, flip it over. If you want to travel at the speed of, or as you get closer to traveling at the speed of light, your mass actually increases. So you need more energy. You don't just need the energy to go faster, you need the energy to overcome your increased mass. And as you reach the speed of light, your mass increases infinitely. And so you need an infinite amount of energy to move at the speed of light. That's why photons, particles of light, are massless. Yes. Everyone else would be long dead. Okay, here we go. That's because Angel was talking to Numrit. You understand why I assumed you were, right? Okay. But it wasn't you this time. Okay. More energy is being absorbed than is needed. Earth gets warmer. Flip the page. Here's the problem. Hands up if you ever built a greenhouse. Hands way up high if you ever built or been inside a greenhouse. Okay. What's the purpose of the greenhouse? Imparis. To trap heat. Means you can grow plants any time of the year, which sounds great, but when your planet that you're living on functions like a greenhouse, it warms up more than it should. So greenhouses are designed, for those of you who don't know, greenhouses are designed so that light can come in, bounce around on the inside, and then get trapped. Not all of it gets to go out after it has come in. And so you get this area, this little building, that is way warmer than the surrounding environment. Even in the winter, greenhouses are substantially warmer than the environment outside without having to do any extra bonus heating. Okay. Mr. DeVries got angry. He just walked out the door. So what we've got here, and the Earth, okay, and don't get me wrong, the Earth needs this to a degree. We have an atmosphere that functions like a greenhouse. Like on the previous page, that heat comes in, the thermal energy from the sun comes in, bounces out, stays inside. It's necessary. This is a good thing. The problem is we've added to it. We have pumped more CO2 into the atmosphere. You pump more CO2, increases this layer. This layer gets thicker. This layer gets thicker, more energy gets trapped. More energy gets trapped, things get warmer. The warmer it gets, the more water vapor gets produced, and water vapor is itself also a greenhouse gas. So you start to have this compounding effect of increased warmth. You have a lab for me. That is so great. Throw it in the bin. Last lab. High five. Okay. There are more greenhouse gases over here. B-bin, yeah. Just throw it on top. Nitrous oxide and methane. This is from a few places. It's from vegetative rot. Vegetation rotting. This is also from cows, which doesn't sound like a big deal. But we as a human race, we love our cows, man. We love our cows. Either you're part of the group of people who eat the cows, or there are portions of people who revere the cows. Cows are sacred in certain world religions, and so they're not killed there. We like the cows. So as a human race, cows are a popular creature for a bunch of reasons. Cows require a ton of energy and a ton of space. Angel, Numrit, Memphis, Imparis, stop talking, please. I know you are, but I want to explain something here. I want you to hear it. So because we as a human race have this obsession with cows, we have created space, Soham, to harvest the cows. As a result, we have deforested millions of acres of forest. Deforesting causes an increase in CO2 because those trees pull CO2 from the atmosphere. You cut them down to grow cows, not only are you cutting down the forest, meaning the CO2 is going to continue to build up, but you're producing cows. Cows produce a ton of methane. Ha ha ha, cows fart. But that's actually a serious contributor. The gas produced by bovine is a massive contributor to greenhouse gas emissions into the atmosphere. Interesting. Greenhouse gases cause the Earth to become warmer. This leads to an increase in ocean temperature. All you need is a 3-degree increase to destroy coral reef. And coral reef destruction leads to ecosystem destruction all over the world. Glaciers melt. Ocean waters rise. This is bad for people. I don't know if you've ever paid attention to this, Numrit and Malik, but the vast majority of the locations that people on our planet live is on the coast. The first settlements were on bodies of water because it's easy to move around once you're on the body of water, whether it's a lake or a river or the ocean. So the vast majority of major cities would be wiped out if the ocean's levels continue to rise, even a couple meters. Like densely populated areas, Los Angeles, toast. New York City, toast. Most European capitals, London's gone. Paris, gone. Basically all of the Netherlands, gone. So many of these places are right on the ocean. If the ocean levels continue to rise, these major cities are going to disappear. Angel, yes. No, what were you going to say? Yes. Yes, there are South Pacific islands that are disappearing because, yes. Yes. No, it's the opposite. Well, no, it is like Atlantis. Yes. Okay, so it's not all gloom and doom. It's gloomy, but it's not all gloom and doom. It's important to recognize that there is a brighter side. And then this is it. The end of me. Initiatives are being taken. Were being taken until recently. Can anyone tell me the last large event in human history that is contributing to the downfall of positive initiatives in relation to the energy of their... Something happened recently that was a huge blow to environmental initiatives. What? No, more recent than that. Michael, you had your hand up? Sorry? What about? Something, as a human race, well, a portion of the human race did something that is having a catastrophic impact on environmentally positive processes. No. Well, electric cars, well, no. 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 You can pin most of the responsibility for this on one dude who just came to power because a bunch of people were too stupid to vote for him. The U.S. election down in the States. We, as a human race, there was a bunch of countries that were devoted to. There's some major countries that aren't. China never signed on with this, and until China signs on to be part of the solution, I mean, it's going to be hard because China's a massive manufacturing nation. But the United States was a part of this group of nations that was working together to create globally sustainable solutions to energy primarily. And then they elected Donald Trump. And he killed a ton of these different initiatives. Initiatives about sustainable technology, initiatives about reducing energy consumption, initiatives about more reliable renewable energy. As a group of countries, this is something we're trying to do, but we did just take a huge step backwards with the election that just occurred in the United States. So that's a thing. I don't know if you realize though, but we currently, Malik, Memphis, and Paris, Numrit, I know, but I'm still trying to teach you things. Then I'll stop for a second. You know what? Here, I'll do this. You guys have 3 minutes to say whatever you want to the people sitting around you because there's a lot of social energy. Go. In 3 minutes, I'm finishing my lesson. No, Karndeep, you may not use the washroom until I'm done. Which one? Yes. Yes, I will. I haven't yet, but I will. Yes. Karndeep, if you can be back in 2 minutes, you can go to the washroom too. Was it Washington? I think it was Washington. Oh, Abraham Lincoln was way later. I think it was Washington. Yes, George Washington. George Ferguson was the mayor of Abbotsford. Careful, that's a whole bunch of that's mine. I just couldn't contain them, so I gave them 3 minutes to talk about whatever they wanted.
That's okay. I can't contain my class.
Okay, time's up. Let me finish.
Thanks. Hold on, just in case.
Okay, here we go. No, Memphis and Paris, done. Your 3 minutes is up, not a word. My turn. Let me finish this, and then I am done for the year. So, there are still positives to all of this. Little things, bitty things that people can do, kind of humorous things that are resulting, though. Abbey was built to be, this school was built to be an energy efficient building. The materials that went in, the design of those certain areas, the fact that we use geothermal heating, a whole bunch of areas of Abbey were designed to be environmentally efficient or energy efficient. I mean, recycling is a thing. There's problems with recycling, though. Does anyone read or watch the news? Like in the last couple days, Abbotsford made the news as it relates to our recycling programs. Did anyone know to read that? Okay, cool. It's hilarious. Vikram, Abbotsford is going to get fined $175,000 because the citizens of Abbotsford continue to contaminate their own recycling. So Abbotsford has a recycling program. That's what those blue bins and blue bags are for, Vikram. I want you facing away from Memphis and Paras. Spin your whole body. I want you looking at the front. Better yet, I want you looking at me. Vikram, I want to see you. People continue to contaminate their recycling with electronics, with books, with foodstuffs, and as a city, we're going to be fined unless people stop doing this. So if this is a conversation you need to have with your parents, like it's going to cost our city money, but it is ridiculous that we pump up the environment, the necessity of our environment to be a thing, and then Abbotsford is trashing on our own environmental recycling program. It's just kind of ridiculous. No, the city is getting fined. Sorry? We are a city. Not that it matters, we're getting fined. So, I'm done. There is hope, but more needs to be done. So you have a test for me on Friday. It's actually, I'll call it a quest. A quest, it's like it's a real beefy quiz. It's like a quiz test thing. What does it mean? It's like a quiz, but bigger. It's like a test, but smaller, somewhere in the middle. Friday. You guys, your reviews are up here at the front. There's 3 stacks. It's the 2 on the right are the ones you need. There's a set of review questions here. You need to be able to do all the calculations that we've already done. The kinetic, gravitational potential, spring potential, and so on. I'm trying to explain to you your test. You need to be able to go back and forth between these kinds of energy because energy is going to be conserved on this test. And you need to do a bunch of calculations. I will give you the formulas and I will provide you with a periodic table so that you're able to do the nuclear stuff that shows up on there as well. Memphis. It will also be there, but I want to assess you on it before you get there so you can see the kinds of things that are going to show up. So, yes, Luca. Let that be next week's problem. Yes. Grab your reviews. Take a look at these questions. Nope. This desk right here, it says on the board, Science 10. The 2 stacks on the right. On your mark, get set, giver.